Okay. Okay. So why do we need to learn this? Because I believe most of you will be familiar with the handling of homogeneous solution, right? And this complicated wave function, high order ODE, is relative to if you can understand, fully understand this, you will find it's highly relative to, it's similar to the solution of homogeneous high order ODE. So let's try to. So I would like to let you understand how to use the mathematic operation to help us learn some complicated science or some fundamental for the basic electronics. Because if you want to handle all of subatom particles, it's basically for quantum. What does quantum mean? It means it's not continuous. So if your energy is not continuous, it's first discovered in black body radiation, Haiti diffuser. So Planck come out this. So people found that the energy state is not continuous. It looks like some discrete states. So you can find this property will be quantized. So that's the first issue. And after that, Einstein come out with an idea with a photon. It's a particle of wave. You can imagine the wave, the light is an electromagnetic wave, right? So a very important experiment called 光电效应, right? If a light comes into the material, and people will find some electron come out. So light beam, but electron come out inside the material. So it's another evidence that the second critical issue is that the duality of wave and the particle. So for the subatom, for example, electron, how to describe the electron? How can you describe the traveling of electron inside the circuit? You need a mathematical operation to describe how the electron traveling or moving in the space, in any space, for example, in the circuit. So you can find it could be described with a wave, or it could be described with a particle. So another very famous experiment called De Broglie wave. So it's relative to momentum, 动量. So it looks like a particle. And this is equals to h is a Planck coefficient over lambda is relative to wave. So the experiment is relative to the duality of wave and particle. So how can we describe the behavior of the subatom particles, for example, electron? Or if you notice that some kind of material, or in other words, most of the material could show superconductivity, 超导, is relative to a pair of electrons. How does the two electrons could couple together? Because in between the two electrons, we have to combine with the phonon. It's relative to the vibration of the lattice. So, because most of you are material has an expertise on material science, right? So, if you can understand the science behind the material, it will be very helpful for the future science or advanced technique. So here, if we look at this, the momentum 动量 will be relative to the derivative with respect to space, for example, x. And in the quantum mechanics, the energy will be relative to the derivative to the time. And all of this looks like very difficult. But if we can calculate to solve this kind of solution, you will find the solution is exactly same to the homogeneous high order ODE. So what does Heisenberg uncertainty means? It means the momentum will be related with x. And energy will be related T. So if delta P, the variation of momentum is highly reduced, at the time the delta S will become very, very big. It means the location are not determined precisely, right? It's called uncertainty. So if you want to handle quantum-related system, especially for the subatom particles, you will suffer from the issue uncertainty. So people, in the past, people would like to use probability to describe the distribution of the particles. Either the particle would be behave like a wave or a particle. Okay, so you can find that if energy is precisely identified, but at the same time, you cannot confirm the time precisely. So it's a very famous theory called Heisenberg uncertainty. That is the reason if we want to get into the quantum system, we really need some basic calculation. So we really need a mathematical calculation to help you understand. So here, I just let you know how to solve this equation. Actually, each